Hi there, Addy. Today we are going to do lesson number 38 for you, okay? And lesson number 38 is really fun because it goes over adding and subtracting numbers that have decimals in them. So I think that'll be pretty straightforward to you. Enjoy that part of the lesson because then it's going to get a little bit more complex. We're going to go over squaring and square roots of a number. So it sounds like you already know the concept behind this. When I asked you yesterday, you seemed to know that pretty well. This is going to sort of explain how you get to those numbers, okay? So I need you to pay a lot of attention to this lesson because I want you to understand this completely before we move on to the next thing in the next lesson, okay? So pay lots of attention. Don't skip ahead. If you miss a second, you're going to miss a lot, okay? Love you, Addie. Bye.
Okay, hi there, Addie. Today we are going to do lesson number 38, and this one is super fun, and I think it's going to even go over some new things that you haven't been taught, at least in a lot of depth in school. So, woo, a lot of new things we're going to learn today. So, this is going to be super fun. So, I'm going to jump right in, and first we're going to start out with mental math. Okay, so the first thing that we're going to do is we're going to start counting by sixes from 6 to 72. And I gave you a beautiful picture here of honey, dripping honey. Isn't that like super satisfying to see? Okay, so when we count by sixes, what I'm going to try and think about doing is I'm going to do 6 times 1, 6 times 2, and that's kind of how we count by sixes if we kind of look at these the whole time that we're doing it, and I think we can get there all the way to 72, okay? So here we go. We're going to start with 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, and then 72. All right, cool, we did it. Now let's try and think of doing the same thing this time with sevens, okay? Because this is kind of how we count by sevens if you're not used to doing it, okay? And then we'll get all the way to 84. So we're going to have to multiply, by 8, by 9, by 10, all the way. We'll try it, okay? So we'll start with 7 times 1. Let's see, let's do this. We'll start with, there we go. We'll start with 7 times 1, okay? So 7, 14, 21, 28, 35, 42, we're here, 49, 56, 63, 70, 77, and 84. Okay, perfect, Addy, good job. Let's go on to the rest of mental math, okay? So try and do these in your head. We're going to start out with 4 times 600, and we're going to add to that 4 times 25. Write your answer. Okay, next we're going to do B, which is 875 minus 125. Okay, how about C? Let's do 56 minus 19. Maybe you would subtract 20 in your head, right? Alrighty, let's go to D. D is fun because we're subtracting money, kind of like this monkey, just throwing money away. D is $10 minus $6.25. So if you had a $10 bill and you bought something for $6.25, this will tell you how much change you should expect back. How about E? What is 1/2 of 150? F? This is kind of a new one compared to what we've done before. $40 divided by 10. You're going to have to pay lots of attention here to get the right answer. And then G. Okay, this is one of those long ones, so let's try and pay attention, okay? We're going to start with the number 10 plus 10. Now subtract 2, divide by 3, multiply by 4, add 1, multiply by 4, divide by 2, add 6, and divide by 7. I'm just going to go through that one time because I have a feeling this is going to be a long lesson. So, all right, let's move on to problem solving. But if you need to hear that last problem again, just go ahead and skip back and you can hear me say it again. Problem solving says Teresa has one of these block cubes, right? And she wants to paint each face of it. So maybe it started out just plain wood or something, and she wants to paint this side and then paint this side and paint this side and all the other sides too. Now, she doesn't want to paint red touching a red area. right? And she doesn't want yellow touching a yellow area. And so she wants to use as few colors as possible because that's less packages of paint that she has to buy. So that makes sense, right? So what's the least number of colors that she has to use so that no colors are touching? And I had to kind of think about this, and I would say, like if we're if we're looking at maybe this square right here, like that face, how many other sides is it touching? It's touching one, two, one on the bottom and one on the side because it's a square, right? So it's touching four sides. So maybe that'll help you figure out how many colors of paint she needs. But I'll let you think about that, work through it, and see what you come up with, okay? So pause it here and see if you can figure that out, because for me that would take a little bit of time. But I'm going to move on to the new concept. Now, don't be afraid like this baby about new things. Isn't that a cute baby? It's like laughing and then, whoa, something new. Okay, so we're going to go over the new concept. And the first part of this new concept is that here below we're showing two ways that you can write $3. So you can write it like this one on the left where there's no decimal point and it's just a whole number, or you can write it with a decimal point and then these are like the number of cents, right here. Those are the number of cents. Okay, so the same thing is true for whole numbers. You can write whole numbers with a decimal point or without a decimal point. So here you have a whole number, no decimal point. Here you've put one at the end with nothing after it. And here you've put one at the end with a zero after it, but you still haven't changed the number, right? It's still 3. And here there's 2 zeros after it, but again, you have not changed the number here, is still 3. Okay, and they're all equal to each other. But the reason they say this is because sometimes it's helpful to have a decimal point, just like this little kid is helpful to this little puppy. Look how helpful he is. Oh, it's so cute. So just like that, decimal points are sometimes helpful. And you're going to see that they might be helpful in this lesson. So like when we're adding or subtracting numbers with decimals or without decimals, they are helpful. For example, let's try and add 12 plus 7.5. Now, when we add decimals, you remember that we have to line up the decimal points, right? So I'm going to put 12 right here, okay? And then I'm going to grab this 7.5 and put it here, but this is not the proper way to line it up. Because where would the decimal point be on the 12? The decimal point would be right here, right? That color doesn't quite match, does it? Okay, it would be like right here. Now, so the decimal points aren't lined up unless I add this, and I like to add maybe a 0 so it matches the other one. So now I'm going to grab this and now I'm going to line up the decimals. And you can see that now, since we put a decimal on this first one, that it makes it easier to do this problem. Okay, so let me move this up so I have a little bit of room. And I'm just going to add these together. Okay, so I'm going to put a plus sign. Now I'm going to add everything to the right of the decimal. So everything over here, 0 and 5, and that's going to be just 5. I bring that decimal down. 2 plus 7 is going to be 9. And then right here, 1 plus 0. Now I didn't write a 0 here, but you can. 1 plus 0 is going to be 1. So the answer here is going to be 19.5. But you can see that what I had to do to get that answer is add a decimal point to the 12 and then line up the decimal points so they match. Okay? All right, let's do the next one. Example 2 says they want us to subtract 12.75 minus 5. Okay, so I'm going to pull this down. Now the 5 does not have a decimal point, but we can always add one to make life a little easier for us, right? So I'm just going to add 5.00. And the reason I'm going to add that is because it has two decimal places past the zero, or two place values, I guess, past the decimal, and then it'll line up with the one above. Okay, so now I'm going to subtract. This is a subtraction problem. So we're going to go 5 minus 0, and we'll get 5. And then we're going to do 7 minus 0, and we get 7. Now these decimals line up, which is perfect, so I'm just going to bring that decimal point down. And then I'm just going to do, you could borrow, but I'm just going to think, what's 12 minus 5? And 12 minus 5 is going to be 7. Okay, so the answer is going to be 7.75. Okay, alrighty, let's move on to the next new concept. And I hope you're not too like, what? What is going on? Kind of like this doggy who is super cute. But we're going to go on to squares and square roots. And the first thing that you're going to have to do is a little bit of review. So remember, like this, remember, like Mufasa. Oh wait, that's Simba. That's Simba, not Mufasa. Remember, like Simba. So when we find the area of a square, what we do to find the area of the square is we multiply the length of the square and the length of this side. So it's a square, so it doesn't matter. It's not like a rectangle height times width, but if it's a square, it's kind of like height times width. It's the length of one and the length of the other. And you multiply that by itself to find the area of the square. So the area of that square would be 5 times 5. And what I would get for an answer is 25. Okay, and that's how you get the area of a square. Now that's where the term square comes from. So if they just give you a single number like 5 and they ask you to square it, what they want you to do is make it so that what if 5 is the length on a square and you have to turn that into a square. And when you square the number 5, you're going to get 25 because you multiply it by itself. 5 times 5 is 25. That's how you square it, because you're literally like making a square where each length is 5 and figuring out the area. So when you say 5 squared, right here, 5 squared, that means 5 times 5, which is 25. Now another way to write 5 squared is to use an exponent. So we take a number like this, and if we want to square it, what you do is you add an exponent. And an exponent is you make the number little and kind of up and to the right. Okay? And 5 squared, when you see it like this means, what if I make a square where each length is 5? What's the area of the square? And the area of the squared is 5 times 5, which is 25. So the answer to a problem like this, 5 squared, is 25. So, and the way I would say that is what I just said, I guess. 5 squared equals 25. So that's where the model of the square, that's where you get the expression squaring a number. You square a number by multiplying the number by itself. So whenever you indicate squaring, you use this exponent of 2. So this is called an exponent. Okay, so I'm going to write exponent. When you use the exponent of 2, it means 5 times 5. Or whatever number you're squaring, it means this number squared. And this number also has a name. Okay, whatever number you put there, that's called the base. So the base is what you're squaring. So the base is going to be used as a factor, 5 times 5, in this case 5. So you factor it twice, 5 times 5. Let's do some examples and it'll sink in a little bit more, okay? So let's do example 3. What is 12 squared? So you could write this a different way. Let me do that. It could be 12 squared. So this means that the base is 12 the exponent is 2, and what they want you to do when you see that is multiply 12 times 12. Kind of like having a square where each length of the side is 12. Whoops, is 12. And you're finding the area. Okay, so 12 squared here is the same as 12 times 12. And I think you know what 12 times 12 is. It's 144. So the answer, what is 12 squared? It's 144. Okay, now this next problem B, it says simplify 3 squared plus 4 squared. Now, we haven't talked about order of operations in a while, but whenever you have exponents like this is what you're going to do first. You do it before you add, before you subtract, before you multiply, or before you divide. So here's what we're going to do. 3 squared, that can simplify to 3 times 3. Okay? And then 4 squared, that's going to simplify to 4 times 4. Now these are a little bit like your mental math problems, right? So 3 times 3 is 9. And 4 times 4 is 16. And then when you add those together, you're going to get 25. Okay, and so that's the answer of this problem right here. 3 squared plus 4 squared is 25. Okay, so we're going to go on to the next page, 199. And it says here, and it's a small little sentence written here at the top, but it's a very important sentence because it says that we can use an exponent of 2 with a unit of length. And that means that you're measuring not a length anymore, but you're measuring square units that are actually an area. So for example, if you just have 1 centimeter, then that's a length. That means you have a line, and that line is 1 centimeter long. Okay? But if you add an exponent of 2 to the word centimeters, now you have 1 centimeter squared, or it's also called 1 square centimeter. I'm going to write that down. 1 square centimeter. That's how you would say it if you saw those things together. And that means you don't have a unit of length, you actually have a square, like this one. And 1 square centimeter means that you have a square where each length equals 1 centimeter. This is 1 centimeter, this is 1 centimeter. They're all 1 centimeter in length. And then the area means all of this in between. It's the area, not the perimeter, not anything like that. It's the area. Okay? Alrighty. Let's go on to example 4. And example 4 says, what is the area of a square with sides that are 5 meters long? So here's my square. I know that this is 5 meters and this is 5 meters. So how do I find the area of the square? Well, easy peasy lemon squeezy. What we're going to do is we're going to find 5 centimeters and we're going to multiply 5 centimeters. You could also think of it as 5 squared. Okay? So, but it's not, I made a mistake. It's not centimeters, it's just meters. Okay, so I'll take that away. Now, when you do 5 meters times 5 meters, it's kind of like saying 5 times 5, and then the units also multiply. Meters times meters. Okay? And so what you end up with is 25, because that's 5 times 5. And what if you do meters times meters? Well, meters times meters is the same as meters squared. So when you do units that are in area, it's super important to get your units right. And the units are going to be in squared units. It could be meters squared, centimeters squared, inches squared, miles squared. yards squared or feet squared, right? It can be any of those things. So those are, the answer here is 25 meters squared or 25 square meters. All right, now we have to think backwards because the next part is, what if we know the area of the square, but we don't know the lengths of the sides, right? So you can figure that out. If you know the area of a square, you can find the length of each side. And the trick is to knowing that if it's a square, then that means that this length, I'll just call it L, is going to be the same as this length, L, right? So it's going to be L times L is equal to 49 in this situation, 49, right? So here's what we do. When you know the area of a square, you have to think to yourself, what do I multiply by itself in order to get this number? So it's going to be, if L is multiplied by itself and I get the answer of 49, what number do I think this is going to be? And since you're good at your times tables, you probably remember that 7 times 7 is 49. And now the units on the 49, as you see over here, are going to be centimeters squared. But what are the units on each length? It's just 7 centimeters. So 7 centimeters times 7 centimeters equals 49 centimeters squared. Okay, because you are multiplying this by itself, but you're also multiplying centimeters by itself. All right, now when you do it backwards like that, determining the length of a side when you're starting out with the area of a square, that's called finding the square root. Okay, so there's a way you can find the square root. So finding the square root of a number is the inverse operation of squaring a number. So for example, this sentence here, 6 squared is 36. That means that 6 squared equals 36, or 6 times 6 is equal to 36. Now the inverse operation for all of this is finding the square root. And the square root of 36, when you're talking about the square root of a number, you use this symbol. And this is the square root. So if you're trying to find like the square root of 36, what you would do is you would make this symbol and put 36 on the inside. And then you have to figure out what number, when you multiply it by itself, is equal to 36. Okay, and the answer here is 6. Whoops. There we go, is 6. Okay, so 6 squared is 36. The square root of 36 is 6. And this is the square root symbol. Okay, now we read you read this symbol as the square root of 100. And so basically what that means is what number, it's going to be a positive number, when you multiply it by itself, has a product of 100. And since you know your times tables again, you're going to figure out that 10 times 10 equals 100. And therefore, the square root of 100 is just 10. Okay, so this is the answer here. The square root of 100 is 10 because 10 times 10 is 100. Okay, alrighty. Now, what about a perfect square? Perfect square. That sounds really cool, doesn't it? Basically, a number is a perfect square if it has a square root that is a whole number. So sometimes when you are looking for the square root, it might be 3.5, because you could have a square that is like 3.5 that way, 3.5 this way, and that's not considered a perfect square. But if you have a square that has the length of the side as a whole number, like 7 and 7, or 6 and 6, or 5 and 5, then the number on the inside is going to be perfect. Okay, and so a perfect square is something like these. I'm going to show you some examples. So this square, this little square, has, let's assume that each, let's do like each side is just 1 centimeter. Okay, so this is going to be 1 centimeter this way, 1 centimeter this way. And so how do we find the area? The area is going to be 1 times 1, and it's going to be 1 centimeter squared. Okay, because I did 1 centimeter times 1 centimeter. So that means 1 times 1 and a centimeter times a centimeter. So that's 1, because 1 times 1 is 1. And then the units are squared, so it's centimeters squared. Okay, perfect. Now, that means that the area here is 1. And when you have the number 1, the square root of 1 is 1. And that's a perfect square. Okay, let's do the next one. What about this one? This has, if this is 1 centimeter, then we're going to have 1 centimeter and 2 centimeters, and 1 centimeter and 2 centimeters this way, right? So we're going to be 2 centimeters that way, 2 centimeters this way. So how do we find the area? Area equals 2 times 2, or area equals 2 squared, and 2 times 2 is 4 centimeters squared. Okay, so the area on the inside now is going to be 4 centimeters squared. I'll just put 4. And similar to that, the square root of 4 is 2. Because if you have the area, if they tell you that the area of a square is 4, then you know that the length of each side is 2. Okay, what about the next one? This is 1, 2, 3 centimeters across, 1, 2, 3 centimeters down. So we have 3, 3. The area is going to be 3 squared, which is equal to 3 times 3, which is equal to 9 centimeters squared. Now, what is the square root of 9? That means that the square root of 9 is 3. So the area is 9. Okay, let's try the next one. This is 1, 2, 3, 4 centimeters across and 4 centimeters down. So we have 4 centimeters, 4 centimeters. What's the area going to be? The area is going to be 4 squared, or 4 times 4, or 16. Now, if I know the area, let's say they don't tell me the length of the side, they say the area is 16. Well, turns out 16 is a perfect square because the square root of 16 is 4. All right, very good on those. Let's go on to the next example. And this example says, simplify the square root of 64. And it turns out 64 is a perfect square. So you can think about this in a couple ways. You could say, well, what if there's a square, okay, and I know that the area is 64. What does that mean about the length of each side? Okay, so what number times itself equals 64? And we figure out, because you know your times tables, that the square root of 64 is 8. Why? Because 8 times 8 equals 64. So this would be 8, this would be 8, they would all be 8, the length of 8. And in this example, it doesn't give us units, but if this were centimeters squared, then this would be just plain centimeters. Okay. All right, Addie, that is the whole lesson. So we are inching along to new and better things, and I will let you practice these concepts with your homework, and I hope you enjoy it. Have a great time. So excited to see what you do, okay? Love you, bye.